Okay, so again, theorem 3.8 states that if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So we know a linear pair is 180 degrees, and if we have two angles that are in the linear pair that are congruent, they're each 90 degrees. And 90-degree right angles are formed by perpendicular lines. Yes, question? All right, anybody still need the slide? All right, let's go on. Theorem 3.9 states, if two lines are perpendicular, then they intersect to form right angles. So all four of those angles, 1, 2, 3, and 4, are all right angles, and they are created from the intersection of the lines that are perpendicular. Next, theorem 3.10, if two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So what this states is if we have the sides, we have two adjacent angles, 1 and 2, and if the sides of 1 along with the side of 2 are perpendicular, then 1 and 2 together are complementary, because again, we know that perpendicular lines form a 90-degree angle, and if it's shared between two, they're complementary. Next theorem. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So here is our transversal. It is line J. And if it is perpendicular to one of the lines, and they've got the little right angle here, then it's perpendicular to the other line. This one actually has a name. This one is theorem 312, but it's called lines perpendicular to a transversal theorem. And what this states is, in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So we have our two parallel lines, and they're perpendicular to the transversal here, this line P. Yes? You're going to have to restate them. Yeah, we're not going to memorize the names. You'll just restate it if you have to give it as a reason and a proof. So here, if two lines are perpendicular to the same line, then they're parallel to each other. Here we go with the distance formula. So from a point to a line is the length of the perpendicular segment from the point to the line. So this is going to be the shortest distance. So when you're given a line and a point, the shortest distance is going to be the perpendicular segment. And then the other one is between two parallel lines is the length of any perpendicular segment joining the two lines. So here's our distance formula again. I'll write it down because we're going to be using it. The distance formula is x2 minus x1 squared plus y2 minus y1 squared, and it's all under a radical. We're going to be using the distance formula to find the length of the perpendicular segment. Now, before we can do the distance formula, we're first going to have to do the slope formula to make sure they're opposite reciprocals to confirm that they're perpendicular. So this homework is going to have a lot of calculations. Okay, here's our first example. In the figure, angle 1 and angle 2 are congruent. What can you conclude about the measure of angle 2? What do we know about angle 1 and 2 here? What kind of angles are they? They're congruent, and they're supplements because they're a linear pair. So if they're supplements, how much do supplementary angles add up to be? 180. And if they're congruent, how much is angle 2? 90. So angle 2 here is 90 because they're a linear pair, and they're supplements, and they're congruent, so they're 90. Pretty good on this one? All right, let's get example 2. Here we're going to do a proof for this. So it wants us to prove that if this is given to us, that angle 1 and angle 2 are complementary, they want us to prove that BA is perpendicular to BC. So I'm going to write a proof. Here are my statements. And then I'm going to set up my reasons. What's going to be my first statement?
Given.
The given. Okay? So, and my given is that angle 1 and angle 2 are complementary. Yes.
I was just going to say this next one.
Okay, you're going to tell me the next. Okay, what's the next one?
Wouldn't it be that angle 1 and 2 equal 90 degrees?
Beautiful. Angle 1 plus angle 2 equal 90 degrees. And that reason is?
Wouldn't that just be the definition of complementary angles?
Good. Definition of complementary angles. That is step 2. Step 3. What do you think we're going to do next? How about how the big angle's made?
Maybe it's like angle 1 plus 2 is equal to angle ABC.
Okay, good. Angle 1 plus angle 2 equals ABC. And that is the angle addition postulate from way back when. All right, now what are we going to do?
Wouldn't you just say how angle AB and angle BC is just perpendicular?
All right, we got to put one more step in here, because what do perpendicular lines form?
They form a 90 degree.
Good. So what we're going to do is we're actually going to substitute, or we could even say transitive. So I'm going to actually just say that ABC equals 90 degrees. And that's substitution, or you could say transitive. And then 5 would be what you're trying to prove, that AB is perpendicular to BC by definition of perpendicular lines, because we have a right angle there. It says determine which other lines, if any, must be perpendicular, and explain your reasoning. What lines are perpendicular here?
Lines A, B, and C.
Okay, so for sure we know for a fact that B and C, correct? Because we've got the right angle, correct? This is perpendicular. But how can we show that angle A is also perpendicular to C?
Corresponding angles.
Good. The converse, first we're going to show that A and B are parallel. So we're going to show that A is parallel to B by the converse of the corresponding angles postulate. So converse of corresponding angles postulate. And then from there, we can say that A is perpendicular to B, and we're going to restate the theorem we just learned. And we're going to say, if a line is perpendicular to one parallel line, then it is perpendicular to the other. So first we have to identify that the lines are parallel, and now that we've said that they're parallel, then if it's perpendicular to one parallel line, then it's perpendicular to the other. So that was one of the theorems that we just learned. One more slide. This is where we're going to use the distance formula. Anybody still need this? Okay. Oh, all right. Last example, it says, what is the distance between the two parallel sides of this tabletop? So we learned that the shortest distance or the distance between two parallel lines is the perpendicular segment. So what I need to do is drop a perpendicular segment here. So I'm gonna go ahead and draw a perpendicular segment from one parallel side to the other, and I could draw another one right here. So the first thing I need to do is confirm that these are parallel segments. So I'm going to calculate the slope of this and the slope of this. And then once I do that, I'm going to make sure that they're opposite reciprocals. If they are, then I can calculate the distance of this segment. So first thing I'm going to do is calculate the slope. So I'm going to use the 4, 6 and the 0, 3. So when I do 6 minus 3, let me use a different color. So 6 minus 3 over 4 minus 0. And it gives me 3/4. Now I need to calculate the slope of the perpendicular segment that I drew down in red. So that segment is going to be 3 minus -1 over 0 minus 3. And then I get +4 over -3. Notice the two slopes are opposite reciprocals. So the two lines, the perpendicular segment and the side of the tabletop, are perpendicular, or the segment I drew in here. Now I'm going to calculate the distance of this segment right here. So again, I'm going to use the distance formula. I'm going to use the order pair 0, 3 and 3, -1. I'm going to use the distance formula, and I'm going to do 3 minus 0 squared plus -1 minus 3 squared, all under a radical, 3 squared plus -4 squared, 9 plus 16, 25, square root it, the length of that, or the distance between the two tabletop parallel sides, is 5 units. Now, if it wasn't a perfect square, you would have to simplify the radical. We're not using a calculator, so you need to leave it in simplest radical form. So you're going to be doing this. In the homework, it's not a figure. It's just going to be a line and a point. So it won't be this complicated. But you're still going to have to calculate the slope and find the distance. So, and what I mean, just to clarify out simplest radical form, let's say your answer ended up being the square root of 8. Okay, we need to break it down. So I could do like 4 times 2. If you realize right now you're at a perfect square, you could just do 2 radical 2. If you didn't realize that, you'd still keep breaking it down. So you need to leave it in simplest radical form. Break down the radicals on any of the distance problems. Homework is practice B. It's due tomorrow morning, 8 a.m. And I will announce tomorrow in class when your quiz will be, due to the possible RADAS meeting on Wednesday. We might move it.